Today's class topic is methods of data acquisition. The number of detector channels included in the detector array are dependent on the model of scanner used. The number of detector channels included in the detector array are dependent on the model of scanner used. The number of detector channels included in the detector array are dependent on the model of scanner used. The number of detector channels included in the detector array are dependent on the model of scanner used. The next is axial scanning and helical or spiral scanning. The next is axial scanning and helical or spiral scanning. The next is axial scanning and helical or spiral scanning. The next is localizer scan. The first area is the localizer or tropogram. The second area is the tropogram. The third 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 area is the tropogram. The position of the tube determines the orientation of the image. If the tube is positioned above the patient, the resulting localizer scan will be anterior-posterior. If the tube is positioned above the patient, the resulting localizer scan will be anterior-posterior. If the tube is positioned above the patient, the resulting localizer scan will be anterior-posterior. If the tube is positioned above the patient, the resulting localizer scan will be anterior-posterior. If the tube is positioned above the patient, the resulting localizer scan will be anterior-posterior. If the tube is positioned above the patient, the resulting localizer scan will be anterior-posterior. The third area is the lateral tropogram. The third area is the gantry and the fourth area is the XA tube. The third area is the patient and the fourth area is the detector. The XA tube has the detector on the opposite side. We want a topogram from the neck to the pelvis. We want a topogram from the neck to the pelvis. The XA tube must be positioned above the patient. The XA tube must be positioned above the patient. If the XA tube is not scanned, we will get a lateral topogram. We will get a lateral topogram. We have an option in our software. The option is written as Lateral Scout or AP Scout. If we select the Lateral Scout, the tube will automatically come here. If we select the AP Scout, the tube will stay above. Lateral Scout is used for the spine. We can get a lateral topogram by scanning the head. We can get a lateral topogram by scanning the head. The XA tube is not on the top. The XA tube is on the side. The XA tube is on the side. Lateral topogram is used by scanning the head. Lateral topogram is used by scanning the head. Lateral topogram is used by scanning the head. We can understand how the topogram works. The topogram does not move around the patient. It is located on one side, maybe on the side, maybe on the top. Now we see the localizer names. Localization images are called by various names, depending on the manufacturer. The localizer images are called by various names, depending on the manufacturer, the company. The terms are scout, survey, which machine has scout, which machine has survey. Or which machine has topogram, which machine has scanogram, or preview, and pilot. They have all been used to describe these images. These words are used. In all routine studies, at least one localizer scan is required. Before testing all these, we need to take a localizer. The optimal scout includes all areas to be scanned and therefore ensures that the anatomy to be imaged has been placed within the range of the system. That is, within the topogram image, the anatomy we want to cover must be there. Miscentered localizer scans can lead to erroneous calculations of tube current and can affect image quality and the detection dose to the patient. If we do not center properly, then we will not get a proper localizer. If we do a brain-based CT scan, then we have to center the image in the blood vessel. But if we do not center properly, then we will not get a proper localizer or topogram. Then we will have to repeat the localizer again. That means the patient's radiation dose has increased. Proper centering of the localizer scan is particularly important when automatic exposure control options are used. So, KVMS automatic exposure control is used in many machines. So, in the end, we must center properly. On all CT systems, it is imperative that the operator input the correct directional instructions before data acquisition is initiated. That means, each CT system must give a directional instruction. That means, the patient must know the position of the patient's head or foot before the machine. So, there is an option in the machine for this. Head or feet first. Head first or feet first. How the patient is sleeping. He is sleeping with his head or head up. So, the patient is sleeping with his head up and a head up. And there is a decubitus position. That means, the patient is sleeping with his head up. So, the patient is awake. These information must be given to the machine. Then the machine can give the proper message. If the operator accurately enters the information into the system, the software correctly annotates the localizer image and all subsequent cross-sectional images as the left, right, anterior, posterior and superior, inferior. That means, if the operator correctly enters the information into the machine will be able to recognize the image of the localizer. So, if the operator correctly enters the information into the machine will be able to recognize the image of the localizer. If the operator incorrectly enters the information into the machine will be able to recognize the image of the localizer. Now, let's see what the problem is. If the image is upside down, the localizer is upside down. For example, the heart is on the left, but the heart is on the right. The image is upside down. The left side of the heart is on this side, but the left side is on the other side. This is the liver is on the left side, but the liver is on the right side. If the patient's position is not good, then the image will be reversed. As I see this axial image, what is written here? It is written P, meaning posterior. But this is not the posterior of the patient, this is the anterior part. Posterior is this. Again, this side is written left, but this side is the right side. This side will be right and this side will be left. Because the image here is not good. Because there is no shorting input, meaning the patient has to enter. Localizer images also help the technologist select the optimal display field of view and the correct image center. Why do we need a localizer image? We need to select the axial plan, how much field of view of the plan is taken, we select it as a localizer. And where will the center be? Although both of these parameters can be adjusted after the study is completed by using the raw data. If we can study this area again, we can reconstruct the raw data. Display field of view and image center selection is often improved by including a second localizer scan taken at 90 degrees from the first, both AP and lateral. As you can see, it takes a lot of time to take two topograms. This is APM, lateral. Then it is more convenient to position and plan. So, you can see beautifully what our slices are reading on. In addition to using localizer scans and prescribed cross-sectional slices, they are also used once a study is complete. Localizer images are more useful in the future. For example, when we check the images, we can see which slice is at which level. We can also write this on the localizer image. These lines represent the location of each cross-sectional image. We can see which level of the cross-sectional image is at which level of the body. But we can see it on the localizer image. This cross-sectional image is on this line. Now, we can see the step in shooting scanning. As we can see earlier, the older traditional method of scanning is referred to as axial scanning, or conventional scanning, or serial scanning, or sequence scanning, or step and shoot scanning. The key to this method is that the CT table moves to the desired location and remains stationary while the XATU rotates within the GNT collecting data. As I said earlier, the step and shoot scanning technique is an old technique of CT scanning. The CT table moves to the desired location and remains stationary while the XATU rotates within the GNT collecting data. This is the step and shoot scanning technique. Now, there are advantages in step and shoot scanning. In evaluating image quality using phantoms that do not breath or move, step and shoot methods result in the highest image quality superior to that of helical methods. The advantage of step and shoot method is that the image quality is superior to that of helical methods. In the case of phantoms, when quality is checked, the quality of the step and shoot method is better. This is because of their axial nature. Slices are perpendicular, not slanted, and the fact that the patient table remains stationary during data acquisition. The quality of the scan is better because the CT table does not move while data collection. The axial scan can be programmed to acquire data for contiguous slices, in which one slice abords the next, or in a non-contiguous fashion, in which some areas of the patient are skipped between slices or slice data overlaps. The axial scan can be done continuously, but there is a gap in the image. Because the scan is not done in certain areas, only the selected slices are scanned. For this reason, all current scanners offer the option of axial scanning. Although helical scanning has replaced many axial protocols, there are still a number of procedures in which axial methods are preferred. Some companies have still put the axial scanning system in their protocols. But the protocol has been replaced by helical scanning. Helical scans are done first and collect more information. The more the scan area is done, the more information the helical scanner provides. There are disadvantages of the step and shoot. The primary disadvantage of the axial method is that the cumulative effect of the process between each data acquisition adds to the total examination time. The cumulative delay may be less than 30 seconds, but the cumulative delay is often significant. This is particularly true when blood vessels, which remain contrast-filled for very short periods, are of primary interest or when a patient's breathing will result in motion artifacts on the image. We need to take a direct scan. Because when we push the patient's body, the contrast will not remain in the patient's body for long. The scan must be done in the patient's body. This scan must be done directly. Because the step and shoot method does not require a direct scan. In addition, compared with helical data, data acquired with the step and shoot method are more limited in how they can be reconstructed. The step and shoot method is limited in the information we get from the helical data. Even after reconstruction, the data is not fully recorded. The delay inherent in axial scan sequences decreases the likelihood that a patient will be able to hold his breath without the examination. When the axial scan is over, the patient will not be able to hold his breath. When a scan sequence is longer than a single breath hold, the scans must be briefly suspended to give the patient time to exhale, take in a new breath and hold it once again. If we cannot finish the scan, we must take the scan twice. The patient will not be able to hold his breath. This can result in slice misregistration, which occurs when a patient breathes differently with each data acquisition. This is a very important point. What is misregistration? When a patient breathes differently with each data acquisition, the patient will not be able to hold his breath. The patient will not be able to hold his breath. When a patient breathes differently with each data acquisition, the patient will not be able to hold his breath. The machine does not understand the data acquisition. The machine does not understand the data acquisition. This is a problem. Here is an example of misregistration. Slice misregistration caused by patient breathing. We can see that a patient breathes differently with each data acquisition. A patient breathes differently with each data acquisition. A patient breathes differently with each data acquisition. These two slices are taken at a contiguous stable position. This is the last slice in the first group of axial slices. This is the last slice. This is the last slice. The patient was allowed to breathe and then once again asked to hold his breath. The patient breathed, and when he saw that the last slice was at the same level, the liver was slightly swollen. But when the second scan was done, the patient was able to breathe again. It is just 5 mm more inferior, yet to appear dramatically more inferior. It is possible to miss lesions as large as 1 cm as a result of size misregistration. The first slice was on the liver dome. The first slice was on the liver dome. It means that there is a misregistration of the slice. This is because of the breathing. The single detector Rose system was used in both the third and fourth generation systems. In the third generation system, approximately 700 detector elements were arranged in an arc. In the fourth generation system, approximately 4,800 detectors were arranged in a single row. In a single row, in a complete ring, so many detectors were used. In a single detector row, each detector element is quite wide in the z direction. Where there is a single detector row, the detectors are positioned in the z direction. The opening and closing of the polymeters controls the slice thickness. The polymeters control the slice thickness. The polymeters control how much X will fall on the detector. In the third generation system, there is a detector arc. The arc is parallel to the tube. The arc is parallel to the tube. In the fourth generation, there is a detector ring. There are 4 detectors. There is a 360-degree detector ring and a tube. The detectors collect information. Now let's see how the polymeter controls the slice thickness. If we increase the window, the slice thickness will fall on the detector. Close the polymeter and increase the slice thickness. If we increase the slice thickness, the X will fall on the detector.